Alright, good morning or afternoon or whatever it is when you're watching this. I want to do the kind of a test outline for you and then go over the review, some of the problems on the review. Answers are posted, of course, but if you want me to do a video explanation of them, that's what this is for. So first off, the test, no calculator because of the graphing mostly. Your calculator knows how to graph. I want to know if you know how to graph. So no calculator, 20 multiple choice, 4 free response. Multiple choice are similar to the ones on the review and the ones on the quiz. So some of those are the 1, 2, and 3. 1 is true, 2 and 3 are true. That sort of embedded multiple choice thing. 4 free response questions that'll be that will have partial credit attached to them, and then 1 bonus question that is not super difficult. It's a topic it's just the algebra is kind of tedious and a little bit extra. So you're all capable of it. It's just I encourage you to take the time and give it a try, and I think you'll be okay. And that'll also be partial credit, I think, so you may get some of the bonus but not all of it. Lastly, for the virtual people, it'll be posted in Schoology and it'll be available at 6 a.m. on Wednesday and due by Wednesday at midnight. For the in-person folks, it'll just be a regular take the test in class like any other normal test. Alright, on to the review. Again, I'm not going to work all of them because there's some duplicates and you probably don't need them all, but I'm going to work a pretty good chunk of them and try to hit everything along the way. So, number 2, function form by starting with the quadratic parent function. So y equals x squared. Now, they're all quadratic, so that doesn't really help a whole lot. 3 units right, so that would be x minus 3. 5 units up, so plus 5. And then it's squared, so let's see. I want an x minus 3 squared and a plus 5. That would be a. I'm not going to do average value because we've done a couple of them recently, and I hope you know average rate of change. Excuse me, not average value. Average rate of change is just slope y2 minus y1 over x2 minus x1. Picking out a graph, not real difficult. Number 5. Which of the following is true? H plus G. So H plus G would be 6x minus 4. So 1 is true. I don't know how many of you use this sort of strategy, but if I know 1 is true, I can start looking already and I can throw out C. So I can start narrowing down even though I've only done one of the statements. G minus H. So G is 2x minus 5 minus H. So here's the trick to this one. Make sure you distribute the minus sign to everybody. 2x minus 5 minus 4x minus 1. And yep, there's the mistake that they made. So that would be negative 2x minus 6. So 2 is not true. So anything that says 2 in it, I can throw out. So it's either, down to 2 answer choices. G of h of x. G of h of x. So G of 4x plus 1, which means I'll look at the G function and plug in 4x plus 1. So the G function is 2 times the input minus 5. So if I put 4x plus 1 in there and distribute, I'm running out of space, 8x plus 2 minus 5 would be 8x minus 3. I don't know where the 19 came from, so not 3, so 1 only. Great example of a problem that is one problem, but we forced or tricked or whatever got you to do 3 different algebra problems in one there. Number 7, the difference quotient. Again, for now, well, for this year, we're always going to give you the difference quotient. That'll change next year, but for now you're good. There's f of x. I need f of x plus h. So f of x is input squared, x plus h squared, minus 2 times the input, plus 3. So I got a lot of cleanup work here to go. So distribute and FOIL. When you FOIL, some of you are leaving out this term, or you're forgetting that there's a 2 on it, so be careful. Alright, now I've got f of x plus h, so I can plug that in. I've got f of x, I can plug that in. So x squared plus 2hx plus h squared minus 2x minus 2h plus 3. All of that's f of x plus h minus x squared minus 2x plus 3 all over h. So that's a lot of stuff to keep up with, but you know that everything over here should cancel. X squared cancels, 2x cancels, 3 cancels. So let's see what's left. 2hx plus h squared minus 2h all over h. And then we'll look to simplify that. Alright, so looking for things to cancel. They've all got an h. Again, for us, this always happens. For that h, we'll divide into everybody. So 2x plus h minus 2. 2x plus h minus 2. That one's D. Number 8, graph the functions. So parent functions and transformations here. 1 over x. Again, you don't have to sketch the parent function, but I find it helpful. Makes me remember and think about what function should look like. I don't have to list the transformations, but I think it's helpful. Write 3 up 2. Right, 3 up 2. So there's like my new origin, my new starting point. And I know that there are asymptotes there for this particular graph. And the key points are 1, 1. So there's my new function that's been moved right 3 and up 2. Reciprocal function. Number 10, piecewise function. So there's a wall. Remember, build a wall at x equals 2. So this is not part of the graph, but it's helpful to put it on there because now I know left of x equals, or left of 2, I'll graph 2 times the absolute value of x, and right of 2, I'll graph absolute value of x minus 1. So 2 absolute value problems. So on the left, let's see, let me remind myself, absolute value looks like that. So 2 times that would just be stretched by 2, or sort of have a slope of 2. So up 2 over 1 on either side, up 2 over 1. I hit the wall when I go up 2 over 1 again. And this one owns the wall, so a closed circle at the wall for this particular graph. On the other side, there won't be there'll be an open circle because it's not equal to. Alright, x minus 1 means I'll go right 1. So I switched to a pencil because I knew I was going to land in the wrong neighborhood. So I'm going to go right 1 and do my arrows from there. But this is the wrong neighborhood, so I can't really start until I get to the wall. Open circle at the wall, and then up from there. And of course I grabbed a pencil without an eraser, so it's going to be tricky to erase. So that's a pretty good way to do it. If you want to see what the function looks like, is graph it like normal and then erase where it's not supposed to be. That way you only have one function in each neighborhood. That's a good check when you get to the end. If there's a neighborhood that has two functions in it, then somebody's in the wrong spot. Somebody's going to get hurt. So erase, figure out who needs to go where. Number 11, domain. Let's see, domain. There's only two issues with domains: denominators and square roots. Peeking ahead at number 12 there. So a denominator can't be equal to 0. You could factor that if you want to. You might be able to tell by looking what x can't be. So however you get there, x can't be plus or minus 2. And that's the accurate answer, but we want our answer in interval notation. So we want to exclude 2 and negative 2. But we want to make sure we include the space between negative 2 and 2. So sometimes people put answer choice B, but that leaves out negative 2 to 2. A little tight on space for a number line, but if you needed one, you could put one in. Negative 2 and 2 are open circles. Everything else is good. Number 12, square roots. Well, you can't square root a negative number, so 2x plus 5 has to be greater than or equal to 0. 2x greater than or equal to negative 5, x greater than or equal to negative 5 halves. Number line if you need it, but most of you can get from here to, let's see, to here without having to draw a number line. 13, similar to one we just did a few minutes ago. 14, you guys are pretty good at that. Skip ahead to 15, an inverse. Okay, to find an inverse, switch x and y. So that's the y. I'm going to start this up here so I have plenty of room. So x equals 2 over y minus 3 minus 2. So now's the fun part. Everybody can get that far. That is the inverse. So that's not wrong, but I've got to solve for y so that it looks like one of these guys. So I'm trying to get y by itself. Let's add the 2 over. And then what can we do? We could flip both sides. We could multiply both sides by y minus 3. That might be the easiest thing to do. And then divide by x plus 2. And I'm trying to rearrange things so that I get y by itself. I'm almost there. So y equals 2 over x plus 2 plus 3. So 2, just looking at my answer choices, 2 over x plus 2 plus 3. There it is. So again, the trick there is not the first part. The first part's easy, write an inverse. The trick is getting all the algebra steps till you get to the end. 16 you're good with. 17 you're probably okay with. I do want to say, don't forget to do this column first, this column second. Right? If x meets this criteria, then use the equation. Use the criteria column and then the equation column. Again, people make mistakes when they plug it into all three and then try to make a choice. No, pick which one to use and then plug it in. And we'll do one of them, h of negative 2. Let's see what that is. So negative 2 is less than negative 1, so we'll use this one. So 3 times negative 2 squared minus 4. 3 times 4 is 12. 12 minus 4. Oops, sorry, that was minus 8. And 12 minus 8 is 4. So A is true. Although be careful, this one says which of the following is false. So I can mark A out because it's true. Seems kind of backwards, but it's a backwards question. You've seen some of those. Be careful, read carefully on those. check the posted answers if you want the rest of number 17. Number 18. The graph of y equals f of x is given on the right. Which of the following is true? Okay, x-axis symmetry. There's my x-axis. If I folded this graph on the x-axis, it would not copy onto itself. So that's a no. Y-axis symmetry. Well, here's the y-axis. If I folded it on the y-axis, it would copy onto itself. So I'm thinking B is it. But let's keep going to make sure that that's our answer. You guys know that as a multiple choice strategy. You know, once you think you got the right one, rule the others out, and then you'll feel really good about your answer. Origin symmetry. Remember, that's rotate 180 degrees. Sometimes it's hard to picture when you only have one graph, but that's not the same as what I started with. That's like an M, and the original was more like a W. So, no, not origin symmetry. No symmetry. No, we said it had y-axis symmetry, so our answer is B. 19, writing equations. Most of you are really good at that, so hopefully that's not an issue. So the last page here. Number 20, very open-ended question. What can be said about the symmetry of that graph? Well, this is the three tests that we want to do. The y-axis test, x-axis test, and the origin test. So y-axis is negative x in for x. So y squared equals 4 times negative x minus 4. I can tell that that's not going to be the same as the original because of the minus sign. So no on y-axis. X-axis is negative y goes in for y. So negative y squared equals 4x minus 4. Hopefully right away alarm bells go off in your head because you know that the square wipes out the negative. This is how we get the symmetries usually. That is the same as the original, so we do have x-axis symmetry. Just because we have one, we still need to check all three. Origin is change the sign of both. And we put negative y in for y, negative x in for x. And so the y gets fixed, the x gets messed up. So no to origin. So x-axis symmetry. Start looking at our answers. Graph is symmetric with respect to the x-axis only. Yes, I think that's it. No, it's not with y-axis. It's not with the origin. And it doesn't have any symmetry. No, that's not true. So answer choice is A. Again, the point of that one was the three tests. The y-axis test, the x-axis test, and the origin test. While we're here, remember that if it has y-axis symmetry, another word for that is that it's even. And if it has origin symmetry, another word for that is that it is odd. So a little bit of vocab words. We'll see those again in a moment. 21, which is the given graph. You guys are good with that stuff. 22, ask a whole bunch of different things in one question. 23, 24. Here we go with the even, odd, neither business. Let's check 24. So even means y-axis symmetry means negative x in for x. By the way, I don't expect you guys to show all of this work. This is just me thinking out loud and putting my thoughts on paper. If you need to write it out, by all means do so if that helps you think about it. If you need to write a couple of things, that's fine. If you want to jump just plugging things in, that's okay. Do enough work so that you get the problem right, and enough work so that I can tell that you were doing the problem, not your neighbor. So negative x in for x. So negative x cubed equals 5y. Cube a negative, get a negative. Not the same as the original, so no, it is not even. Odd means the same thing as origin. So that's negative x in for x, negative y in for y. So negative x cubed equals 5 times negative y. Cube a negative, get a negative. And then I hope you're paying attention because we've seen this kind of thing before where You look at that and you're like, oh, that's not the same as the original. Look at all those minus signs. Hopefully your brain then says, wait a minute, all those minus signs, something's going on. If I multiply everybody by -1, I get x cubed equals 5y. And we do have the same as the original. So this is an odd function because it has origin symmetry. So I wanted to do that one because of the two negatives thing that sometimes shows up. 25 has a whole bunch of questions associated with it. Check the PDF online for the answers if you want more than that. But I hope this was helpful for you guys. Good luck with the test tomorrow. I do wish I could be there with you. But I'm feeling fine. I just got to wait out the quarantine recovery period so we don't infect anybody else. So hope you guys are well, and I look forward to seeing you on Monday.